Okay, today's lesson we're going to look at completing the square and some foiling and some equations of circles all in one. Alright, so here are some examples of a typical squared polynomial, right? Or in this case a monomial, but you get the idea. A bunch of different squared terms, and I'll do the first one. So remember our foiling, right? First and then outside, inside, and last. That's what it means, right? So first times first gives you x squared, right? Outside is x times -3 gives you minus 3x, and then inside also gives you minus 3x, and then last is the minus 3 times the minus 3, which this is where people make mistakes, is plus 9. Okay, pause the video for a second and try the next one on your own. Okay, hopefully this is what you got. X squared minus 5x minus 5x plus 25. Alright, pause here and try one of the next ones. Okay, so this should be minus 4y minus 4y plus 16. Sorry, this is squared. This is p squared minus 3p minus 3p plus 9. Okay, now pause for a second and see if you can do one of these last two where we now have addition instead of subtraction, and see if you can see where the differences are. Alright, you should have gotten x squared plus 7x plus 7x, and now last times last you still get a positive. In this case 7 times 7 is 49. And this one 6x, 6x, and 36. Okay, so are you starting to see the pattern that you're getting two of the same things, right? You're getting these two items are the same in each of these, right? See, here's a pair, there's a pair, etc., etc., etc. So when you kind of clean it up, x squared minus 6x plus 9, and this one is x squared minus 10x plus 25, right? Y squared minus 8y plus 16, p squared minus 6p plus 9, x squared plus, right, 14x plus 49, and our last one, x squared plus 12x plus 36. Again, are you starting to see the patterns? That you're always getting double this middle. What do you notice about this middle term here on all of these? Even down here, when they're pluses, what do you notice about them? Hopefully you're seeing that the constant, right, minus 6, minus 10, minus 8, right, negative 6, positive 14, positive 12. These constant terms that are in front of the variables are all exactly twice of what we started with. Right? We started with a minus 4 here, and now we have a minus 8. Right? We started with a plus 7, now we have a plus 14. And then you'll also notice the last number. What do you notice about this last number? Or this one? Right? Or this one? Or any of them, they are always just the square of these numbers here. So can we generalize? If we have x minus h squared, right? So h can be any constant we want. We're going to have x minus h times x minus h, and we're going to get x squared minus h many x's, right? Subtract another h many x's. We're going to have an h squared, and when we clean it all up at the end, the pattern will hold, and we'll have x squared minus 2hx plus h squared. So you see how we've generalized it. We know that whatever this number is here, we're going to get 2 of them here, right? So negative gives us a negative, positive gives us a positive, and then whatever this number is, we're going to get a square of it there. That's kind of nice to know that pattern, because that helps us work backwards excuse me, when we have something like this. X squared plus y squared plus 12x plus 2y plus 33 equals 0. And they ask a question like, is it a circle? If it is a circle, where is the center? And what is the radius? And all those types of things. Well, if we remember our formula for a circle, a generic formula for a circle is x minus h quantity squared plus y minus k quantity squared equals r squared. That's an r, sorry. And if we have a circle of this formula, or of this format, then we have it centered over here. It's not a great circle, but you get the idea. It has a radius of r, and the center is h comma k. So if this were, let's say, x minus 2, right? And this was like y minus 1.5, then this center would be at over 2 up 1.5. It's that simple. Okay, so how do we get this stuff on the left to look like this stuff on the right so we can figure out what our center is, or if we even have a circle? Well, we basically have to use these formulas and kind of go in reverse, and that's what's called completing the square. So put your stuff together in families, right? Put all the x's together, and I'm going to leave a gap here, and then I'll leave a gap here. And then most people like to put the constant over on the other side just to get it out of the way. You don't have to. You could just kind of put it at the end as a plus 33 and still have the equals 11 at the end. Doesn't really matter. But now you can see that this piece is going to be one perfect square, right? It's going to end up being something that when you work backwards, it will get you that looks something like this. It won't necessarily be plus 7, but it'll be something of that form. So you can think of it as being something that looks like this, right? And then same thing goes, this piece here will be another perfect square that will again be of the form, but in this case y minus something. Okay, so excuse me. If we're going to make this a perfect square, if it has to hold to this pattern, we see that in order for a perfect square, right, we started with a perfect square here, to get to look something like this, the middle piece has to be 2h, right, and then the last piece has to be h squared. So if the constant here is 12, what does h have to be? And hopefully you're all screaming at the computer monitor that it has to be 6, right, because this is 2h. So in this case, h equals 6. And so then 6 squared, right? If we want to make this a perfect square, don't we have to add in 36? Because that's h squared. But since we have inequalities, can we just add 36 here and not do anything else? No, we also have to add 36 over to the other side of the equation. Okay, we can do the same thing with the second piece. And we can go, all right, well, in this case, what is our h? Well, h is 1. And then 1 squared is just 1. And since we added on the left, we got to add it on the right. And now, look at what you have. X squared plus 12x plus 36, right? Y squared plus 2y plus 1. So this is a perfect square. This is a perfect square. And when we go back and write it in its perfect square format, we know that our h is 1, and is this going to be a plus or a minus? Well, since that's a plus, that's a plus. That's that piece. And then what about this piece? Over here, we have x, and we know h is 6. And again, is it a plus or minus? That's a plus. And then on the right hand side, what do we have? We've got 36, 37, minus 33, right? So that's just a positive 4. Well, that was nice, because now, what does r have to equal? 2, right? So this whole equation, which came from this original one, does in fact represent a circle. Where's the center going to be? Is it going to be at 1, positive 6? Hopefully you're all saying no, because remember the format is x minus h. So with this plus 6 here, that means you go over to negative 6, and because this is a positive 1, you go down to negative 1, and that's the center there. And negative 6, negative 1. And again, I am a crappy drawer, but that has a radius of 2, right? And that would be your circle there. Okay, so that's one of the reasons why we complete the square. It's so we can figure out if these things are circles and where they're located. But it really all boils down to recognizing the generic pattern of these nice, perfect, squared little polynomial pieces. Hope that helps.